Hello everyone. So in the last video, while ending, I said that from the next video onwards, we will be seeing about introduction to complexity. But I thought that it would be a good idea, before starting with directly introduction to complexity, let me talk about a little bit about a algorithm. That is like a most popular searching algorithm, you can say, or say one of the very familiar searching algorithms, because as I have said already, that we will be looking for sorting algorithms, we'll be solving some sorting algorithms, searching algorithms. Why? Because these are really essential stops. Okay. So I thought before straightway jumping into the complexity part, before straightway coming with some conventional words and all these things, let me show you a searching that is really easy to understand. Okay, so let me start today with the linear search. So this topic. So what is linear search? Suppose, say you are given with, or say take this example, students are standing in a queue in a school or anywhere, okay, but it is not roll number wise or anything, there is no such rule, okay. So they are standing in a queue, so you need to find, they are all wearing their ID cards, so you need to find the student with the roll number say 42. So what you will do, you will start from the first student, you will check his ID card, and then you'll be like, no, he is not roll number 42. You will go to the next student, you will go to the next student, and so on. So you will be doing this process starting from a point and up to a certain limit until that student is found, right? And what if that student is absolutely absent that day? So in that case, you will be starting from the first student, you will be just checking, and the queue will end, but you will not find that student, right? So what exactly you are trying to do in your brain? You are trying to search a student, okay, and what way you are following? You are following that you are starting from the absolute first indexing position and you are going one step at a time and you are trying to find that student. And might be in the worst case scenario, the student is not present, even though you have scanned all the students, you have checked all the students' ID card, right? So this phenomena or this particular approach is a linear search approach. So let me see how it works step by step. So as I said in the earlier videos, that an algorithm will be having some steps defined. But before we go straight into the steps that is already written on this whiteboard, I would like to tell you that an algorithm first starts with inputs and outputs. That I have already said that every algorithm should have some input and some output, right? Even though I have said also conveyed that the input number can be 0 or more, and output number has to have at least one output for every algorithm. So for this particular linear search, just now the example I have given, what can be the input? The input can be that, say, how many students in that case? How many students? Okay, and suppose you know in your particular classroom there are 60 students starting from roll number 1 to 60. So what you will do? You will just record in a way, because they are standing in a queue, but not in kind of sequential manner, not in sorted way. They are standing randomly in the queue. So what you will do? You will be just taking randomly their roll numbers and all these things. So you will see that roll number 42 is present or not. So you have a particular all the 1 to 60 roll numbers inside a particular array. Okay, so this is the input for this thing. And what else do you need? Suppose you need roll number 42. So this is the key student. That is, you want to find the roll number 42 or say 42nd student. So in that case, you are trying to find this particular student. So this should go as input, another input. So there are two inputs. One is that array, that how many numbers or what are the roll numbers of the students. This is one input. And the second input is which roll number you want to find. That is the key. I am calling it a key. So that is 42. Now, what will be the output? The output will be, say, if it is found or not. And if found, which position? Which position? So the output is, first of all, we need to check whether that particular value, that particular student is present or not. If present, then in that case, at which position it is present, or you can simply say that this particular student or this particular element is not present. Okay, so now let me now go to the step-by-step algorithm part. So I have written 5 steps over here. So what is the step 1? The step 1 is you start from index 0. Okay, so let me take this kind of an array. So suppose this is an array, and as I am saying that the values are not in sorted manner or anything. Suppose the values are 12, 17, 15, 21, 42, 37. And you want to find the value 42. Okay. So as per array, we always start with index 0. So this is at 0th index, this is at 1, this is at 2, 3, 4, 5, and so on. So suppose these are the roll number of the students. First, who is standing at the 0th position, he is holding the roll number 12. Then the next person who is standing, that is in the 1 position, that person or that student is holding the roll number 17, and so on. Okay, there are say 6 students in this case. So what we will be doing? Now we will be starting from index 0. As I just said, that we will be starting from the first position, this one, right? Next, the step 2, compare AI. What is A? A is this array itself. So A is this array itself. Okay, and what is A of I? A of I is nothing but, if you know the concept of for loop, if you know the concept of array, you know that I is the index number. So these are the I values. These are the I values. 0 is an I value, 1 is an I value, 2 is an I value, and so on. Right? So what is A of I? A of I means which position, that is I is specifying which position, and A of I is saying that in that position what is the value. So I is saying the position is 0, and A of I will say which value is present at position 0. So the value that is present at position 0 is 12. So suppose I want to write A of 0, that will be 12. A of 1, that would be 17, and so on. Okay, so now what we are doing? In step 2, we are comparing AI with the key. So what we are exactly doing? We are checking A of I, that is A of I, for say first it will be A of 0, and A of 0 is 12. So we are checking whether 12 is equal to the key we want to find. What we are trying to find? We are trying to find 42. So we are checking whether 42 and 12, or say 42 or wherever is sitting at this position, these two are equal. Okay. So we do this thing. Next, if equal, then return the index. So first we checked say 12 with 42. Is it equal? The answer is no. If it was equal, we would have returned the index. Index means this 0. We would have said that the position or the value is found at position 0 or index 0. So it is not, found. So then what we do in the step 4, it is saying that if equal, then return to the index, but 42 is not equal to, or 12 is not equal to 42. So that's why we move to the next element. That's what I said, that you move one by one. So if not 12, then you go to the next element, that is index 1. So if you go to the index 1, you do this step again. You go and you check whether this position's value is equal to 42 or not. But you see that this position value is 17 and it is not equal to 42. So it is not equal again. So again you move to the next element. Okay, so you move to the next element, and what is the next element now? Next element is index 2, that is 15. So is 42 or is this value equal to the value present at this index? The answer is no, right? So again you go to this particular thing. Is it equal to 42? No. You go to the next one. It is now equal to 42, right? So it is saying that if equal, then you return the index. So what we are doing? We are basically hovering between these two steps. So what we are doing now, at index 4, we have the value 42. So that's why if it is saying that if it is equal, then return the index. So what will be returned? The index of this particular thing, that is 4. 4 is the index, so it will be saying that it is found at position 4 or index 4. Okay. Now, what if suppose the key was not 42, instead the key was 40? So in that case, it would have been here, it would have been again compared with 42 with 40, and this was not equal. It would have been shifted. The last value is 37. So these two are also not equal, right? So in that case, saying if end is reached, that is this particular value is reached, there is no more element to find, right? So in that case, if the end is reached, still not found, that is 40 is still not in this particular array, so in that case, we would have returned -1. So what this -1 is signifying? -1 is simply signifying that the element is not found. Okay, so this is the whole procedure of linear search. So we will be seeing by the code now. We will be writing down the code and we will be telling you that how we should go with the code part as well. Okay.